Hey there, Joe Braun here, the DCS Mech Warriors. In this video, we're going to attach a DC motor to our gamepad using buttons. Should be number 6 in our series. If you haven't watched any of the previous videos, of course, jump back and start watching those. But let me go ahead and switch over to my desktop. So in this video, what we're going to want to do is go ahead and open up Team Code and Java. And to start out with, I'm going to open up my notes here and go back to the very first video that we created, which was a basic teleop structure. We built this in FTC lesson number 1, I believe it was. I'm going to copy all of this up to the configuration file. So I'm going to push Control C on my keyboard. And then what we're going to do is go down to, I'm actually going to minimize that, go down to YouTube, which is where we've been storing all of our new op modes. Go to New and Java class. You could create yours right in the Team Code folder, or if you have a new package name, whatever you called that, you could create it inside there. But we're going to call this one Motor 1 and push Enter. And so that creates a new Java class inside our YouTube folder with the correct package name and the correct class name. What I'm going to do is come down here on line 5 and push Control V and paste in that op mode that we already created. Now this creates a problem. So we have a class name, and then down here it thinks we have another class name inside this one. So we need to fix a couple things. So I'm going to Control click on Motor 1 and push Control C, come down here to the class name that we copied in and paste that in. And then we still have this same name here, so we're going to get rid of this one that doesn't have anything in it. And now everything's happy. There are no errors. We've got Motor 1 over here inside our package, YouTube package, and everything's correct. So we've got a good place to start. So I'm going to go back to the first op mode that we ever built in the series and close that. But then now I'm going to come and open up my notes for creating our DC motor with buttons. I'm going to move that down to the bottom just so we can see both side by side like I have in previous videos, and minimize the side panel so we have a little more real estate on the screen. Okay, so we're ready to dive into editing this general op mode to make it run this DC motor that we've been talking about. So the imports here, all we have to do is minimize those. Those are going to happen on the fly. Our configuration file, we want to go ahead and make that for our new op mode. Now we're starting from scratch, so it's as if the control hub doesn't have anything on it. So the previous 4 servos, it's like we've disconnected all those and we're starting from scratch, okay? So here we want to go ahead and put the notes that we have on our bottom screen here. So we're going to go ahead and connect to the control hub. And let's go ahead and do a motor port 1. Actually, it would be 0 would be the first one. And we're going to call this motor 1. Let me come up and capitalize the H there. And so I think all of our notes for our configuration file are good. So what you'd have to do is go to your driver hub, click on the ellipsis in the upper right hand corner, go to the configuration file, and then find your motor port 0 and put that variable in so that our configuration file has the same thing that our Java is going to have. The variables will match up. Again, that's called a hardware map. So you got to make sure you do that step. The next thing that we're going to do is take our disabled. You would want to go ahead and comment that out, get rid of it, so that your op mode will show up. But for me, I'm going to leave that turned off. And then we've been putting all of our teleop op modes inside a group named examples. So I'm actually going to paste that in instead of using primary like we would on a competition robot. We'll just put that in the examples group, so they're all grouped together. When you click on the triangle to open up your teleop on the right hand side of the driver hub. Then the class name is already good to go, and we've got this weird name down here for the examples, but that's still fine. And then our override run op mode that we're doing from the parent class needs a few changes. So we've got our init hardware. We do that by default in all of our op modes for our team. Inside the while loop, we need to add our motor telemetry. And that is a function call. So it's going to turn red because we haven't created that function, and that's perfectly fine. Then we're going to wait for start. And then anything we'd want to happen one time, once we press the play button, we'd go in here. But for this op mode, we don't want anything. And then right here, we want our teleop controls. Teleop, what are we calling that? Controls. Just said it, so I guess I should remember that. And then end with a semicolon, and we're also going to call our motor telemetry while we're running our op mode. So there's our method calls that we want inside our big picture. So we try to keep this zoomed out so we can see overall logically what's happening, and not put a whole bunch of things inside here to where it's hard to see, again, the big picture, what's going on with the op mode. So we try to keep this pretty clean and slimmed down, and we put all of the code actually in methods down below that. So what we're going to have to do is create some methods. We already have init hardware by default. So let's go ahead and create a couple more op modes down here. So we're going to need to create a public void. We're going to init motor 1. Trying to remember the variable name. So that will be a method. So we need parentheses and then our bracket, push enter. We're also going to need our teleop controls. So let's go ahead and create a method for that. Void and teleop controls. And then we're also going to need a method for our, did we call it motor telemetry? Yes, we did. Motor telemetry. So public void, I guess the faster way, especially for me, would be just to copy these methods and then change the name, but this will work. So motor telemetry. And there we go. So we have some functions that, so we've still got one that's red, I just noticed, but we've got our functions for some of the things we're going to call. So teleop controls, I didn't capitalize the C. So that is why that didn't call it right there. And so now that's fixed. And then init telemetry is going to go inside our hardware stack. Of course, for this one, it's a little bit of overkill, but as we layer in more and more pieces, this will start to make sense. We'll do that in following videos, but let's go ahead and put in our motor 1. So I'm going to find that in the menu and push tab, and that fills that in. So this method is being used inside our method stack for initting our hardware, which is being called right there. And then teleop controls is being called right there. And then motor telemetry is being called up here. So we're starting to get a little more detail to our picture of what's going on. So now all of these have methods that have been created down below. So again, a method, if you're just joining the series, if it has parentheses in it, this is a method. So we've got our overall method that we're overriding from our parent class, new op mode, our linear op mode. And then we're creating extra methods down here to put the code in to call it up here in the big picture that we're calling run op mode. Okay, so let's go ahead and start adding some pieces in. So what do we want to do with our motor 1? Well, that needs to be set up. So the setup pieces are right here. I am just going to copy and paste those in, and then we'll talk about what each one does. So looks like we have some errors. Let's figure out what's going on there. So DC motor hardware map. Oh, it took me a second. We haven't done our global variables yet, so we need to back up. Right below the class name is supposed to be our global variables, and this variable right here, motor 1, hasn't been defined, so it doesn't know what to do with any of this stuff. So we got to go back up here and put in our variables. So I'm going to again copy and paste that, and then we'll discuss what those mean. So we're creating a variable. It's only limited to this class, so it can't be accessed outside of the class. The variable that we're creating is a DC motor. That's a class call from the parent class up the chain somewhere, and we're calling it motor 1. We're also setting 2 variables ahead of time. We haven't necessarily used those variables yet, but we're setting our 0 power to 0. Hopefully that makes sense. And then when we run the motor, we're going to run our motor at 100% power. You could set that to something else, but for right now, we're going to set that to 100%. So there's our 3 variables, just as we've done in other videos. So now let me go down here, and everything is no longer red. So we can discuss what's going on here. So motor 1, the first thing we want to do is connect it to that configuration file on our driver hub, and so that's called the hardware map. So our variable name in Java is motor 1, our variable name in the config file is motor 1, and it's calling a DC motor class. So hopefully all of that makes sense. Down here, we're setting the motor direction. Right now it's set to forward. We can change this to reverse and push tab so that pops in there, but for now we're going to leave this one as forward. Again, this is an optional step. You don't necessarily have to do that, but if we want to change it, it's already there. We can just look at the setup and we can see what direction it is also. So we always put this in our step or in our setup, even though it's an optional step. We do want to, for safety reasons, go ahead and make sure that we're not getting some weird signal going to our DC motor. We specifically set it to 0 power. So we're going to take motor 1, set its power to this variable. Again, to find that variable, I'm going to push Control, hover over the variable name and click, and it takes me to where that's set. Obviously, 0 power should be set to 0. So I'm going to scroll back down. And then our 0 power behavior. So when it goes to 0 power, is it going to use the motor to slow down, or is it just going to coast to a stop? So the difference between that, using the motor to slow down, is going to be brake. It's not actually using a brake, it's using power in the opposite direction to slow it down to 0. But you can also put in here float. And float is going to mean that it goes to 0 power and just coasts to a stop. It's not going to use the motor to bring it to a stop. So in this instance, we're going to use brake. So I'm going to push tab, and our motor is going to use power to then slow it down to 0, come to a stop. All right, the next thing we're going to do is stop and reset the encoder. So when we initialize this, we wanted to know that wherever it started is the 0 position. Anything that would be held over from a previous op mode as far as encoder data, we don't want to keep that. I don't know that that step's necessarily absolutely 100% needs to be there, but we do it every time. So we make sure when we init, that's the 0 spot. And then we're going to set our op mode to run without the encoder. So there's a lot of confusion on that. At least I had a lot of confusion with what these mean when we set the op mode. So I created some notes down here. Let me scroll down and kind of show you those. So we have different options that we can use when we set the mode. So the first one you see here is stop and reset the encoder. So the encoder's current position is set to 0. So if it was at -100, it would reset it wherever it's at. It would set it to 0. Run without encoder. The encoder data is still collected. That one was a little confusing to me because it says run without encoder. But the encoder data is still collected, but the velocity of the motor is set to the specified power level without a PID controller. So it's not using a PID in the background to correct the motor power. So as opposed to running with the encoder where the PID controller is actually turned on to achieve that specific power level. And then run to position is running using the encoder. So the encoder is turned on. It's going to run to a specific tick count. So if you run it to 1,000, it's going to run to that and stop and hold that position. So hopefully that clears up a little bit of these run modes, set modes, I guess. And we'll use those in the following videos in different ways. So stay tuned through the series. So let me go ahead and continue. So we have all of our init set up. Those are the pieces that we want to put inside our initial setup for the DC motor. So again, that's being called inside the init hardware. This will grow to several pieces over time. We're going to eventually set up 4 motors, I believe, in the series, and then that's being called up here in our run op mode. So our initial setup is done, but we haven't done anything to use this motor other than set it up when you push play, init and play. So let's jump down here and actually put in some teleop controls. So in this spot right here, we want to fill in these right here. So I'm going to copy and paste and then talk about what we're doing. So if this statement is true, and that statement is pushing X on Gamepad 2. So make sure you get that. We've changed to Gamepad 2. Previous videos, we were using Gamepad 1. So this is how you would differentiate between those. If this is true, we're going to run this code block here. Well, we're going to run motor 1. We're going to set its power to negative motor 1 power. So motor 1 power is 100% if I remember right. I'm going to control click on that and it's set to 100%. So when we come back down here, it's running in the opposite direction, so backwards at 100% power if we push X, which is the left button on the gamepad. So if we push A, so that would be the bottom button, it's going to go to 0 power. If we push B, so the one on the right, it's going to go forward at 100% power because there's no negative sign in front of this variable. So I think if you've watched previous videos in the series, that's pretty straightforward. We did the same thing with a servo on buttons. Continuous rotation servo actually. So this is going in the backwards direction, this is the forwards direction, and this is setting it to 0 power. So then now what would we want to do maybe with telemetry as far as outputting data to the screen so we can maybe use it as troubleshooting? Well, I did a little bit of a different setup on this particular one to show you a different way to that you can display your data. So let me Control C and paste that in. So in this case, we're stacking two variables on one line. So the first one is the caption, so that's motor 1, and then the format has a decimal. So I think that actually means double, but with 2 decimals, okay? Because this is a double, the format is different than this one because this number that it's getting is a float. So this is the float notation, so .2f, so that's going to give us 2 decimals, and this one is a double and it's going to give us 2 decimals. I don't know why there's a dot in front of this one and not here, but I know from doing lots of telemetry, that's the way that we need to do this. So on one line, we're going to display motor 1's encoder data and its power level, all on the same line, and give it a couple labels in front. And then this is how we set the number of decimals. So if you wanted it to be 4 decimals, you could change that to a 4. I'm going to push Control Z. There we go. Get it back to 2. Okay, so DC motor, especially if you've been following along with the series, is pretty simple. A few more lines in the setup, but everything else is pretty much the same. And then we added a little twist to the telemetry. But hopefully this is all making sense. In the next video, what we're going to do is take a DC motor number 2 and attach that to a joystick. So it would be very similar to a servo, but hopefully we'll see you in that video. And I think that's it for now. So thanks for watching. We'll catch you in the next one. Bye-bye.